Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 17 of 21. Standard user-defined functions are strictly limited to a one-to-one mapping. You pass in one value, you get exactly one value out. But what if a single dense log entry needs to be expanded into 100 separate rows? To solve this, you use Python user-defined table functions, or UDTFs. A UDTF does exactly what the name implies. It returns an entire table from a single input. While a standard UDF calculates a single scalar value, a UDTF can emit multiple rows and multiple columns. This is the tool you reach for when you need to explode a nested JSON string, parse a delimited text file line by line, or generate a sequence of dates from a single timestamp. To create a UDTF in PySpark, you do not write a basic standalone function. Instead, you define a Python class. This class requires a specific method called eval. The eval method is where the actual transformation happens. When you execute the UDTF, Spark calls this method for every input value. Here's the key insight. Inside that eval method, you do not use a standard return statement. Instead, you use the Python yield keyword. Every time the method yields a value, Spark translates that into a new row in your output table. If you pass a single input string, the eval method might loop through it and yield 10 times. Spark takes those 10 yields and produces 10 distinct rows. Let us walk through a concrete example. You build a class called processWords. Your goal is to pass in a full sentence and get back a table where every word has its own row. You write the eval method to accept a text string. Inside the method, you split the sentence by spaces. Then you loop over the resulting words. For each word, you yield a tuple containing the word itself. Before Spark can use this class, you apply the PySpark UDTF decorator to it. The decorator is mandatory because it defines your output schema. You explicitly declare the column names and data types your function generates. If you yield a string, you tell the decorator the output is a string column. If you want to yield the word and its character count, you yield a two-element tuple, and your decorator specifies a schema with a string column and an integer column. Beyond the eval method, a UDTF class can also include an optional terminate method. Spark calls the terminate method exactly once for each partition of data after all input rows have been processed by the eval method. This is highly useful for aggregation. If your eval method tracks an internal counter across multiple input rows, the terminate method can yield one final row containing that total count before the partition closes. When you call a UDTF in a data frame operation, it behaves like an inline table. If you pass an existing data frame column into the UDTF, Spark applies the table function row by row. Because a table function outputs multiple rows for each single input row, combining this output with your original dataset requires an implicit lateral join. Spark handles this behind the scenes, duplicating the original row data to match the newly exploded rows generated by your Python class. The defining power of a Python UDTF is completely unbinding your input volume to your output volume, allowing a single data point to blossom into a full multi-column dataset. That's all for this one. Thanks for listening, and keep building.